To attempt question like this, the first thing to do is to write out the chemical equation showing the reaction between lead-2 nitrate and hydrogen sulphide. Looking at this is a balanced chemical equation. Then let's proceed. In the question above, we are made to understand that 10 dm³ of the air contained hydrogen sulphide as impurity. So the impurity reacted with lead-2 nitrate and yielded lead sulphide and triazonitrate 5 acid. The lead sulphide that was formed as a precipitate is weighed to be 5.02 grams. We do not know the exact volume of hydrogen sulphide that reacted, but we are made to know the volume of air containing hydrogen sulphide as impurity. No information about lead-2 nitrate, so we'll be dealing with hydrogen sulphide and lead sulphide because they are the two substances whose data we are being given, that is, we are being told one or two things about them. So let's start. For hydrogen sulphide, we do not know the exact volume, but we know the volume of air containing hydrogen sulphide. And for lead sulphide, we are given the mass of lead sulphide. So to determine the volume of hydrogen sulphide that reacted, we need to know the number of moles of hydrogen sulphide. And to know the number of moles of hydrogen sulphide, we'll have to determine the number of moles of lead sulphide. Then we can apply it based on the equation we've written above. Let's start by calculating the moles of lead sulphide. And before we get that, so we're applying the formula that says moles equals mass over molar mass. So the mass of lead sulphide is 5.02 grams, but the molar mass is unknown. So we'll be calculating that as molar mass of lead sulphide. So that will be the sum of the atomic mass of each of the elements present. So for lead, the atomic mass of lead is 207, while for sulphur we have 32. So adding this, that is 239, and the unit grams per mole. So for the moles of lead sulphide, that's mass over molar mass. The mass is given to be 5.02 grams divided by the molar mass, which is 239. Calculating this, we have 0.021 and the unit moles. So we've gotten the number of moles of lead sulphide. So let's go back to the equation above. And from the equation above, you can say 1 mole of hydrogen sulphide will yield 1 mole of lead sulphide. The number of moles is gotten from the coefficient of the compound. So if we have 0.21 moles of lead sulphide, how many moles of hydrogen sulphide will be needed? So here we'll represent that with X. I'll say S moles of hydrogen sulphide will yield 0.021 moles of lead sulphide. So from here, I'll make X the subject. X equals 1 multiplied by 0.021 divided by 1, which is equivalent to 0.021 per unit moles. We can just proceed to substitute the values without showing the calculations, but we are doing that because of cases in which the coefficient here won't be the same. But if the coefficients are the same, you can go ahead to apply the number of moles in the next calculation. So now that we've gotten the number of moles of hydrogen sulphide, we'll proceed to calculate the volume of hydrogen sulphide that took part in the reaction. And to do that, we'll be using a formula that says moles equals volume over amount at s.t.p. So from here, we'll be making volume the subject. So then we can say volume of hydrogen sulphide equals the number of moles which we've gotten earlier, that is 0.021, multiplied by amount at s.t.p, that's 22.4. Calculating this, we have 0.47, our unit in dm³. We've gotten the volume of hydrogen sulphide that reacted, but that is not the end to the solution of the question. We are asked to calculate the percentage by volume of hydrogen sulphide in the air. So we need to determine the percentage of the air in which hydrogen sulphide is occupying. That is, what percentage of 10.0 dm³ of air is hydrogen sulphide. And together, to just say percentage by volume of hydrogen sulphide will equal to the volume of hydrogen sulphide itself, which is 0.47 dm³, divided by the volume of air, that's 10 dm³, multiplied by 100, because we are working with percentage. So if you calculate this, we have 4.7 and our unit percent. So this will serve as the final answer. So with this, we've come to the end of the solution to the question, and we've gotten the percentage by volume of hydrogen sulfide in the air to be 4.7%. That will be all. Don't forget to subscribe for more if you find this video helpful.